Nope.
Okay, for Unit 13 group quiz, okay? Factor completely. This is just like one of the Q problems. So if we did Q squared minus 36, that would be Q plus 6 and Q minus 6. Then once it's completely factored, you can plug back in. So 7x minus 4 plus 6 and 7x minus 4 minus 6. Combine like terms, so we get 7x plus 2 and 7x minus 10. If there was a GCF, you would have to take it out there, but this one there is not. So 7x plus 2 and 7x minus 10. Here, again, factor completely. This is just like the Q problem. So Q squared plus 4 times Q minus 12. That would factor to be 1 positive, 1 negative. What multiplies to 12 adds to 4 is going to be a plus 6 and a minus 2. Then plug back in. So 3x minus 2 plus 6 and 3x minus 2 minus 2. If you simplify, we get 3x plus 4 and 3x minus 4. The reason this says M, one of the factors will be, is this is going to be like a multiple choice question. So only one of these answers would be there. But you do have to factor the whole thing to find whichever one is there. Here, this one should be a minus 6 to start with, so fix that on your paper if you didn't listen earlier. Factor our GCF. Left behind is x squared minus 2x minus 3. That's a trinomial, so 2 left behind. You're going to have an x and an x. To get negative at the end, you have to have 1 positive, 1 negative. What multiplies to negative 3 adds to negative 2 would be negative 3, positive 1. Don't forget the 2 up front. So 2 times x plus 1 times x minus 3. Here, to get rid of the double-decker fractions, you want to multiply to get rid of an x squared and an x, so multiply every part by x squared. If you multiply every part by x squared, here these x squareds will cancel. This cancels out one of the x's. So if we rewrite this, this is 4x squared minus 1 over 2x squared minus x. Factor both of these. This is difference of squares. So 2x plus 1, 2x minus 1. And in the denominator, you can factor out a GCF. Take on x, left behind would be 2x minus 1. The 2x minus 1s can reduce. So you should end up with 2x plus 1 over x. If you don't factor and cancel, it's going to be incorrect. Here, we want to get rid of an x squared, an x, and an x squared, so multiply every part by x squared, even if it's not a fraction. Multiply all the parts by x squared, these will cancel. This one cancels out one of them, and both of these cancel. It's going to leave you with 1 plus 5x plus 4x squared over x squared minus 1. If you want to, because these are all positive, you can rearrange this and you can write it in descending exponent order. You don't have to. You could factor it the way it was, but you can change that. This is going to factor in the numerator to be a 4x plus 1 and an x plus 1. In the denominator, that factors to x plus 1 and x minus 1. The x plus 1s will cancel each other out, so you should end up with an answer of 4x plus 1 over x minus 1. Next page, on number 6, anytime you have a negative exponent, we're going to bury the whatever's attached to the negative exponent. So 1 over x minus 2 over x minus 2. To eliminate the fraction there, you're going to multiply every part by x. So if you multiply everything through by x, these are going to cancel. So we get 1 minus 2x over x squared minus 2x. Okay, technically you can take out a GCF here. So 1 over 2x divided by x times x minus 2. Nothing is going to cancel there. So it stays just like this. Nothing cancels. Same thing here. Bury your negative exponents. So 1 over a to the 8th minus 1 over b to the 8th divided by 1 over a to the 4th plus 1 over b to the 4th. To eliminate all of these denominators, you're going to multiply everything through by a to the 8th, b to the 8th. Multiply every part, a to the 8th, b to the 8th. These can cancel, so the a to the 8ths cancel, here the b to the 8ths cancel. You can at least reduce some of these away. They don't cancel completely, but you can reduce a bunch of them away. In the numerator, you're going to end up with b to the 8th minus a to the 8th over a to the 4th, b to the 8th, plus a to the 8th, b to the 4th. In the numerator, that's difference of squares, so that is b to the 4th plus a to the 4th, and b to the 4th minus a to the 4th, excuse me, over, take out a GCF in the denominator of a to the 4th, b to the 4th. Left behind would be b to the 4th plus a to the 4th. Okay, these are exactly the same, so they reduce each other away. This is left behind with b to the 4th minus a to the 4th over a4, b4. Technically, you could take and factor this again. It would be difference of squares 2 more times, but you don't need to factor anymore because you know that there's not going to be anything to reduce it with in the denominator. So you don't have to do that. Here, if we want to solve, okay, solve means you need a factor set equal to 0. So here, to factor this, it's already set equal to 0. You probably want to do over-under factoring, or bottoms-up factoring. That's n to the 4th minus 13n plus 36 equals 0. What multiplies to 36 adds to negative 13 is going to be n minus 4 and n minus 9. Then, don't forget to bring back the 9. So if you bring back the number in front, if it reduces, you should. If not, you take the bottom, move it up. So 9n minus 4 and n minus 1 equals 0. Set each part equal to 0, so we're going to get just a 1. On this side, 9n equals 4, because I set it equal to 0, so n equals 4 over 9. So 2 different answers there. You're going to get n equals 1 and 4 over 9. Doesn't matter which one you put in, or you write down first. Here again, we want to eliminate the denominator, so multiply every part by 2x. Multiply every part by 2x. Here the 2's cancel, here the x's cancel. If you distribute through, we got 2x squared minus 3x equals 14. Start by getting everything equal to 0. So 2x squared minus 3x minus 14 equals 0. This one, again, we want to factor. So if you do bottoms up factoring, you're going to multiply the first times the last, which gives you x squared minus 3x minus 28 equals 0. That factors to be x minus 7 and x plus 4. Bring back your front number, so bring back the 2. If you bring back the 2, this one does not reduce, so we got 2x minus 7. And the second portion does reduce, which is x plus 2. Set each part equal to 0, so that's just going to give you a negative 2. Here, 2x minus 7 equals 0. If you add the 7 to both sides, you get 2x equals 7. Divide through, x is 7 over 2. So again, 2 different answers. X is equal to 7 over 2 and negative 2. For number 10, solve for x. To eliminate both an x and an x plus 2, you're going to multiply every portion, every part of this, by x and x plus 2. All right. Here, the x's cancel, the x plus 2's cancel. If you distribute through, x plus 2 times 1 is just x plus 2. Plus, x times x is x squared. Equals, these distribute to one another, so x squared plus 2x. Here, if you move the x squared to either side, they're going to end up canceling each other out. Then, since there's no more x squared, you're going to put letters on one side, numbers on the opposite side. So if you move the x, we get 2 equals x. 2 equals x. On number 11, in triangle DEF, what is the value of sine D? Okay, you know this is a right triangle. So anytime it's a right triangle, Sine D, sine is equal to, you use SOHCAHTOA. Sine is opposite over hypotenuse, so if you're looking from D, opposite D is 3 over hypotenuse is 7. So 3 over 7. Opposite over hypotenuse. Hypotenuse is always the one across from the right angle. Number 12, in XYZ, what's the value of tangent of X? So tangent is equal to opposite over adjacent. So opposite from X, we don't know, but you can find that. You can do side squared plus side squared equals hypotenuse squared. So if we need to find this value of X, you could do 6 squared plus X squared equals 11 squared. If you work that out, that's going to give us 36 plus X squared equals 121. Okay, to find that, you subtract, we get X squared is equal to 85. So X is equal to root 85. There are no pairs that can come out of that, so this is just going to be root 85. Then if we want to find opposite over adjacent, opposite of X is equal to the root 85 over adjacent to X is 6. So your value would be root 85 over 6. Again, if we want to solve for Y, okay, if you have a 45, this is obviously another 45, so 45, 45, 90, in a standard or a normal 45, 45, 90, we have A, and A root 2. So here, if we set A root 2 equal to 10, you can solve for either of the A values. So A root 2 equals root 10. To get rid of that, you divide both sides by root 2. Okay. This gives you A equals, since these are both radicals, you can reduce them. So root 10 over root 2 gives you root 5, and that is your missing side. So Y would equal root 5. On 14, if you're finding the value of A, again, we're using the same standard 45, 45 right triangle, so it's always A root 2. So this is telling you if your A is equal to 5, the hypotenuse of that would be 5 root 2. All you have to do is add on a root 2 or multiply by root 2. For 15, in a 30, 60, 90 triangle. Okay, in a 30, 60, 90, if this is 30, that would have to be 60. Opposite 30 is always equal to A. The hypotenuse is 2A. Opposite 60 is A root 3. So here, if we're trying to solve for A, if A is equivalent to A root 3, what must we have to do? I'm sorry. If we're trying to solve for A, the ones that you know are 2A and 16. So if 2A is equal to 16, that would tell you that A is equal to 8. You are actually, this is a bad example. It would be better if we said this was an X or something, okay? If this is 8, if A is equal to 8, then A root 3 would have to be 8 root 3. So the side opposite the 60 is always this divided by 2 multiplied by root 3. So this would be 8 root 3. 8 root 3 should be the correct answer. Determine the length of side X in the diagram. So if you know that in a standard 30, 60, 90, your 30 is always opposite 30. Across from 30 is always equal to A. Across from 60 is always equal to A multiplied by root 3. So if you take 2 root 3 multiplied by root 3,
6.
That gives you 2 times 3, which is equal to 6. So your answer would be 6. Here, if we want to find the value of Y, in a 45, 45, 90, both sides are exactly the same, so the value of Y is 2. It's the exact same thing. Here, if we want to find the exact value of y, in a 45, 45, 90, the hypotenuse is always equal to the side times root 2. So 8 is equal to a root 2. To get rid of that, you divide both sides by root 2. You can't have a radical in the denominator, so rationalize, you multiply by root 2. That gives you 8 root 2 over 2. These reduce, so you'd end up with 4 radical 2. 4 multiplied by root 2. Okay, last page. These are going to use, again, more of the standard triangles. If you're using a 30, 60, 90, find cosine of 30. So in a 30, 60, 90, 30, 60, 90, if you're finding cosine, first start by putting in your a root 3, and 2a. Cosine is equal to, if you put in your SOHCAHTOA, cosine is adjacent over hypotenuse. So adjacent to 30 is a root 3. Hypotenuse is 2a. The a's will cancel, so we end up with root 3 over 2. Root 3 over 2. In a 45, 45, 90, draw your standard. Your sides are always going to be a. Hypotenuse is a root 2. So if you want to find sine, sine is equal to, if you look back at your SOHCAHTOA, sine is opposite over hypotenuse. It doesn't matter which 45 you use because they're both going to be the same. Opposite is always going to be a over a root 2. These cancel. You need to multiply to get rid of the radical in the denominator, and that'll give you root 2 over 2. Use a 30, 60, 90 to find sine of 30. So again, use your 30, 60, 90. A root 3, 2a. Sine of 30, sine is opposite over hypotenuse. Opposite from 30 is a. Hypotenuse is 2a. That reduces to 1/2 because the a's will reduce each other away. Another 30, 60, 90. Find cosine of 60. So whenever you get your test, I would first draw your 30, 60, 90 and your 45, 45 triangle so that you don't forget it and so you don't make any mistakes on that. So cosine of 60. Cosine is adjacent over hypotenuse. Adjacent to 60 is a. Hypotenuse is 2a. Those reduce to be 1/2 because the a's will cancel each other out. Tangent of 30. I'm just going to go back to the same triangle. Tangent is opposite over adjacent. So from 30, opposite is a. Adjacent is a root 3. The a's will reduce. Rationalize the denominator means multiply by root 3 and root 3. And you're going to end up with root 3 over a whole 3. Now, 24 and 25 are a little bit confusing because you've never seen this sign before. This is theta. Okay, so all that's telling you is if you draw a triangle, we're assuming it's a right triangle. If sine of theta, okay, we want to find sine of theta. If cosine is 1 over 3, cosine, according to SOHCAHTOA, is adjacent over hypotenuse. So from here, adjacent to that is 1, hypotenuse is 3. You can find the missing side, that's like your x. So 1 squared plus x squared equals 3 squared. That's 1 plus x squared equals 9. X squared will equal 8, and if you take the radical of that, or square root of each side, gives you 2 root 2. So plug in the missing side. And then we want to find sine from this corner. So sine is equal to opposite over hypotenuse. So from this corner, opposite that is 2 root 2. Hypotenuse is 3. So 2 root 2 over 3. Same thing here. You're going to draw a different triangle. Okay. That, just assume that's your theta. It could be also in this other corner. It doesn't really matter. Tangent is equal to opposite over adjacent. So if from here, opposite there is 1, adjacent is 3, you can also find your missing side. That'd be side squared plus side squared equals hypotenuse squared. Make sure you're plugging things into the right place. 1 plus 9 equals your x squared, so 10 equals x squared. If you take the square root of each side, root 10 is equal to x. So that's root 10. And again, we want to find cosine. Cosine is equal to adjacent over hypotenuse. From this angle, adjacent to it is 3. Hypotenuse is root 10. You rationalize both of those, multiply by root 10 over root 10. It's going to leave you with 3 root 10 over 10. And that's it. Woo!